This is Cindy and Ricky. Today we're going to show you guys how to do a first derivative test.
First derivative test.
Okay. Our original function, f of x equals...
Do you want to zoom in?
f of x equals negative 3x to the 5th plus 5x cubed. So, step 1.
Step 1, you take the first derivative, which from the original function, y equals negative 3x to the 5th plus 5x to the 3rd, will be y prime, which is the first derivative, equals negative 15x to the 4th plus 15x squared.
That's your first derivative.
First step. What's the first step? We should say take the first derivative.
Take the first derivative!
Step 2.
Find your critical numbers. Okay, ready? Which means you set y prime equals 0. Y prime, first derivative. That's right. Okay, so first derivative is negative 15x to the 4th plus 15x squared. So you factor out like terms, and you get negative 15x squared, parentheses, x squared minus 1 equals 0. Set both those equals 0, you got x equals 0 and positive and negative 1.
And these
are your critical numbers.
Yes. What are these, Felicia?
Critical numbers.
Okay. Now,
Step 3.
Step forward because we need to show you these. Come here.
Step 3.
Step 3. So, step 3 is you plot your critical numbers on the number
line, which are negative 1, 0, and 1.
Okay.
So step 4, find your increasing and decreasing intervals.
And you do that by plugging the number below and above your critical numbers into your first derivative. So we started with f prime of negative 2 equals negative 15 times negative 2 to the 4th plus 15 times negative 2 to the squared. And we found out it was a decreasing function. So we're going to put...
from infinity to negative 1, your values are decreasing. Okay, and then now you have to pick a number between negative 1 and 0. So we chose negative 1/2. And you plug it into the first derivative, and then what you get is an increasing value, because your answer is positive. So from negative 1 to 0, your values are increasing.
So then when you plug into the first derivative 1/2, you're going to get a negative value. So it is decreasing from 0 to 1.
And then we plugged in 2 to the first derivative, and we found out it was increasing. So from 1 to infinity, you get increasing values.
So what this means is that the graph of your original function is increasing from 0 to negative, negative to infinity.
Decreasing. Decreasing from
negative infinity to negative 1.
To negative 1. Increasing from negative 1 to 0, decreasing from 0 to 1, and then increasing from 1 to infinity.
Wow, I've learned